In this video, I'll explain what cryptography is, but before I do, I just want to recap what blockchain is. So essentially, blockchain is a growing list of records called blocks, and they're all linked using cryptography. So the main components of a blockchain are usually consensus algorithm. So in most blockchains, it's proof of work, the nodes, the node application, and of course the distributed ledger in which the blockchain operates. Cryptography is a security process in which information is converted into non-readable information. So essentially, it encrypts information or data, um, from, and then the recipient has the means to unlock the data. So it's usually through a public key in which the sender encrypts the data, and then that data is unlocked by a corresponding private key used by the recipient. So now I'll give a demonstration on how cryptography works in a blockchain. For simplicity, I'll just do it in one block. So within the blockchain, data is encrypted through, or data within blocks are encrypted through cryptographic hash, through which data is encrypted into unreadable text. So it's a one-way function. You can encrypt it into something that's completely unreadable, and only the recipient can unlock with the private key. But it is very hard to decrypt. So of course, unless you're the recipient and you have the private key, you can't reverse the process. And in blockchain, the most common cryptographic hash algorithm that's used is SHA-256. So here I'll give a bit of a demonstration. So you can see the hash here, and it changes when I type some text. Within the computer operates through binary language. So each letter consists of bytes, or bits or bytes. So byte is either 0 or 1, and bytes is a string of 1 or zeros. So here these letters could consist of a variety of zeros and ones. But also just to note here that when I change the data, then the hash changes with it. So it acts as a digital fingerprint. So it's good. So it's a way to keep track of different types of data, and also it reflects the changes in the data. But if I also wanted to show something else now, so I'm going to paste a paragraph from one of my assignments. So clearly this is one big paragraph, but what's interesting to note is that the hash function, whilst the data within the hash has changed, but the size hasn't changed. It remains fixed, so you can paste an entire library for that matter here. So it's a really good way to encrypt large data sets without having to worry about the storage. So now I'm in the blockchain section. So as I mentioned before, each block is connected to the previous one, and the cryptography it plays a role in this because the cryptographic hash changes every time I change the data. So as I demonstrated in the hash, but here in the blockchain, it changes the hash of the next block. So here in block 2, I've changed the data, and you can see here the data changer. Let's do that again. Yeah, it changed, and it also changed in the other blocks. So yeah, here you can see that how cryptography works within blockchain is that it ensures that data isn't changed otherwise, and it affects changes and it changes the data in the other blocks, and this is then clearly evident that there has been changes and there's been tampering done. So change in one block will affect the cryptographic hashes in the other blocks, and thus you know that the blockchain has been tampered with.